Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the chemistry revision topics. This is phlegm tests. Of course, the phlegm tests are only for cations, but we'll be looking at all the tests that are included in your textbook. Testing gases, testing cations, as well as anions. For gases, we're going to talk about hydrogen, oxygen, carbon dioxide, ammonia, as well as chlorine. Let's begin with hydrogen. Hydrogen gas can be tested using a burning splint. To do this, the burning splint is going to be exposed to the gas, and the splint will explode with a squeaky pop sound, like that. So looking at the experiment here, we see if you have magnesium ribbon exposed to hydrochloric acid. Of course, this is a metal reacting with an acid. We're going to produce a salt and hydrogen. The salt will be magnesium chloride, but the hydrogen gas coming off here is going to be tested using this burning splint, and it's going to explode with a squeaky pop sound. Next we go to testing oxygen. Oxygen is going to be tested using a glowing splint. Here the glowing splint is going to relight. In this experiment we see a reaction of hydrogen peroxide being broken down in the presence of manganese oxide, producing oxygen and water. The oxygen gas produced can be tested using this glowing splint, and the result is it's going to relight. That is how you test for oxygen gas. Next we go to carbon dioxide. This can be tested using lime water. Again here an experiment involving calcium carbonate reacting with hydrochloric acid. Remember, this is a metal carbonate with an acid. We get a salt, which will be calcium chloride, carbon dioxide and water. The generated carbon dioxide gas can be delivered through a delivery tube to lime water. This lime water is going to turn cloudy or milky, and that will be confirmation that the gas that came off the reaction was carbon dioxide gas. Next is a test for ammonia gas. Here we'll test it using damp red litmus paper. The water will provide a solvent into which this gas can dissolve in order for the reaction to take place. So the ammonia gas is going to turn this damp red litmus paper to blue, and that is going to be the confirmation that the gas was ammonia, since it's the only alkaline gas you're going to study at your level. So this is how the litmus paper is going to change. Next we test for chlorine gas. Chlorine gas can be tested by both damp red or damp blue litmus paper, but it's better to test with damp blue litmus paper because we're going to see two changes. With damp blue litmus paper, it's first going to be turned red and then it's going to be bleached. But with damp red litmus paper, it's just going to be bleached. Let's go to water. We can test water. This is not testing for purity, but just anything that contains water. We can use anhydrous copper to sulphate. If the color changes from white to blue, then that is confirmation that the liquid used contained water. In other experiments, they can use cobalt chloride paper, which can turn from blue to pink. So this is the equation with copper sulfate. We see anhydrous copper sulfate reacts with water to give us the hydrated copper sulfate. This color is going to be blue, as this one here was white. The anhydrous color is going to be white, as we see here, and this is going to be the hydrated after something containing water has been added. Next we go to the cations. We're going to test cations using phlegm tests, and then we'll also use solubility tests with sodium hydroxide to see the color of the precipitates that are formed. We're going to look at how a phlegm test can be carried out. First, the wire used could be cleaned. Cleaning can be done using concentrated hydrochloric acid and holding it in a Bunsen flame as you clean it to remove any residues. Then during the actual test, we can dip the wire into a small amount of concentrated hydrochloric acid, and then we dip that into a small amount of the solid so that the wire can pick up the solid. In this case, remember, the wire is already wet with the acid, so when it picks up the solid, there is going to be dissolution, or some of the solid is going to be converted into a solution, which is basically going to be a salt. And now this is going to be placed in the Bunsen flame, and you observe the color of the flame that is produced. So if the cation is lithium, the color is going to be red, as we see here. If it's sodium, the color is going to be yellow, as we see here. Potassium, the color is going to be lilac, as we see here. Calcium is going to be orange-red, like this one here. And copper is going to be blue-green. You need to memorize these colors, and you need to know the description of how a phlegm test is carried out. Now we go to testing using sodium hydroxide. This will give positive results using some metal cations and this non-metal cation. With copper 2, iron 2, and iron 3, we're going to observe the precipitates, but with ammonium, we're going to see a solution. So the first one is testing for ammonium cation. To describe this, if we have a test tube containing ammonium cation, this could be like ammonium chloride. We'll first add sodium hydroxide to the sample. When we add sodium hydroxide, a reaction is going to take place and ammonia gas is going to be produced, but initially it's going to be dissolved, little of it is going to come off. We heat or increase the temperature so that the dissolved gas, which is a product of the first reaction, can come off. So now ammonia gas is going to come off, but we need to test the gas that comes off. We'll do that by using damp red litmus paper because it's going to turn blue to conclude that the gas coming off is ammonia and therefore the cation should have been ammonium cation. So here we see ammonium chloride reacting with sodium hydroxide to give us the salt, water and ammonia gas, which will be dissolved, and on heating more of it is going to come out from the test tube and that can be tested so that the damp red litmus paper turns blue. Next we go to testing iron 2. Iron 2 plus cation is tested using sodium hydroxide, and when that occurs we're going to observe green precipitates like we see here. To test for iron 3 plus cation, again using sodium hydroxide solution, to the sample containing iron 3 cation like iron 3 chloride, we'll add sodium hydroxide and observe the color changes. A precipitate which is orange-brown is going to be produced like we see here, and that is confirmation that is iron 3 cation. In this case, it's going to be iron 3 hydroxide. Next is testing for copper using sodium hydroxide solution. Again, to the sample containing copper like copper 2 sulphate, we'll add sodium hydroxide and observe the color of the precipitate formed. If the precipitate formed is a blue precipitate, then that is confirmation that the compound we had initially was copper 2 plus, and in this case the precipitate is going to be copper 2 hydroxide. Next we go to the anions. Here we're going to be looking at chloride, bromide, iodide, sulphate and carbonate. We're going to begin by testing the halides, which include the chloride, bromide and iodide. These are all tested using the same reagents. So to the sample suspected to be a halide, we will add dilute nitric acid followed by silver nitrate solution and observe the color of the precipitates formed. If the precipitate is white, that confirms a chloride ion. If the precipitate is cream, that confirms presence of bromide ions. And if the precipitate is yellow, that confirms presence of iodide ions. So the equations for the reactions are like we see here. Sodium chloride with silver nitrate, we get silver chloride, which is the white precipitate. And sodium bromide plus silver nitrate gives us silver bromide, which is going to be a cream precipitate. And sodium iodide plus silver nitrate gives us silver iodide, which is going to be a yellow precipitate. Next we go to testing for sulphate. To test for sulphate, we use dilute hydrochloric acid followed by barium chloride, or we can use dilute nitric acid followed by barium nitrate. The reason for this is because all nitrates are soluble and also most chlorides are soluble. So when we use dilute hydrochloric acid followed by barium chloride, a white precipitate is going to be formed, and this is going to confirm presence of a sulphate. For example, barium chloride plus sodium sulphate gives us barium sulphate plus sodium chloride, and here we see the white precipitate formed. Like I said already, we can also use dilute nitric acid followed by barium nitrate. The key thing is we need the barium cation to react with the sulphate anion, and this is going to give us the white precipitate, which is barium sulphate, required in this reaction or for the confirmation of sulphate ions. Lastly, we test for carbonate ions. To test for carbonate ions, we will use dilute hydrochloric acid. So to the sample suspected to be a carbonate, we will add hydrochloric acid. The gas coming off is going to be tested using lime water. Like we see, it's going to be delivered in the delivery tube to the lime water. And if the lime water turns milky or cloudy, that is confirmation that the gas was carbon dioxide and therefore it was coming from a carbonate. So in this experiment, we see calcium carbonate reacting with HCl to give us the salt, which is calcium chloride plus water, and then CO2 gas. This is later tested using lime water, and we see the observation that the lime water turns milky or cloudy as a confirmation for presence of carbon dioxide and therefore a carbonate anion. So this brings us to the end of this video on flame tests. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.